this is Jasper. I'm the CEO and co-founder of Hyperbolic. I'm here to present you the future of AI, which is collaborative and open. Let me start with a self-introduction. I did my math PhD at UC Berkeley. I finished in 2 years, which makes me the fastest person to finish a PhD in the history of Berkeley. During my PhD, I was doing topology and hyperbolic geometry. This gave me the idea of the name of my future company, Hyperbolic. And before that, I graduated from Peking University with the highest honor, Student of the Year. I won a few gold medals in various mathematical competitions. And after graduation, I worked at Citadel Securities and Avalabs before founding Hyperbolic Labs. My co-founder, Yu Chen, has an expertise in AI. He graduated from University of Washington with a PhD in CS, especially AI systems and networking. And after that, he was working at an AI company, building an open source AI compiler called Apache TVM. And we founded Hyperbolic Labs 2022 and have raised a few rounds and keep moving the limit of open source AI. We have a team of, we have like a strong advisors group. There are co-founders of Databricks, Renaud Singh, and also a few professors from UC Berkeley, Columbia, and Hong Kong universities. So our mission is that we want to build an open source AI ecosystem economy. We believe that AI is the most powerful tools known to the mankind. Currently, AI is already integrated with most important systems, and in the future, it will be further integrated. For example, transportations, social media, finance, vehicles, robotics, and even your brains. And currently, in the centralized ecosystems, there's no way for you to participate in controlling this advanced technology, neither let you own and participate in the revenue sharing opportunities. And so at Hyperbolic, we want to build an open AI ecosystem economy of the people, by the people, for the people, where AI infrastructure, services, and models are accessible to all of you, and it can be governed and contributed by all of you and benefit all of you. So a lot of people have shared the same mission with us, and we're glad to see more and more open source and Web3 AI projects working in this field. However, we see there is a biggest problem in order to achieve that dream, which is we need real, robust, decentralized infrastructure. And so the first step that we're building is that we try to build this decentralized AI cloud to enable open access to AI, and we're solving 3 major challenges. The first one is that we want to build a decentralized orchestration layer to aggregate global GPUs, and also we want to build AI services that can leverage the power of heterogeneous compute. So the first part is we call it Hyperbolic Decentralized Operation System. So as long as you have a machine or a cluster, and once you install this HyperDOS, your machine will be seamlessly integrated with our network, and it will allow users on the demand side to easily access the compute and orchestrate all the global compute. We already launched our limited alpha version a month ago, and we're currently doing testing with invited users and also our supplier partners, including Web2 data centers like Lambda Crusoe, Web3 data centers like Foundry, NextGen Cloud, and also tokenization project, GPU tokenization project like Aether, Exabit, and Gabe and Compute Labs. So if you are interested in accessing the compute, reach out to me after the talk, and we can give you access to the limited alpha version. And on top of that, we think that what people really want are actually not just compute. They actually want services and models. And so as the first party, we try to build this AI services layer, allow developers to deploy different AI services, leveraging the global compute that we have. So we first built this AI inference service to host state-of-the-art open source AI models, leveraging the decentralized compute on network. We call it Hyperbolic Compiling Service, which can compile different high-level machine learning language like PyTorch, TensorFlow, JAX into different low-level hardware language like CUDA for NVIDIA, ROCm for AMD, Metal for Apple, etc. And we're currently working with AMD together to push the limit of the AMD chips. And on the right-hand side is like some comparison of the performance between our solutions and another widely adopted serving framework for LLMs on AMDs. We launched our service 4 months ago and has been adopted not only by Web3 AI projects, but also Web2 AI developers. We're currently trying to build our AI community because we think the biggest problem for Web3 and decentralized AI is that we need to get adopted by Web2 people. And we build like this like very friendly user experience, UI UX, and we currently seeing more and more AI developers using our products. And some people have the question that like if we build a decentralized solution, we actually like harm the performance or reliability of the services. And our answer is that we actually can deliver comparable performance to centralized solutions. And this is why Web2 people really like us. And in the future, we'll keep trying to build comparable performance. But then in the meantime, we'll also unlock some extra functionalities powered by blockchain and Web3. The second goal that we're trying to solve is that in a decentralized network, how do you make sure that the results generated by a random node is actually correct? And this is called like security and verifiability. People mention about using consensus, which is like voting. You ask several nodes to run the same request, and then ask them to vote on their answers and see which one get the majority vote. But however, this has like a huge overhead. If you ask 10 nodes to run the same request, it means like 10x overhead. And then people also say we can use OPML, which is like using optimistic mechanism and fraud proof to verify the result. So it means that you ask a node to generate the result, but then you will wait for 7 days, which is called a challenge window, allow other people to challenge the result. But this doesn't give you great finality. So as a user, if I ask AI model, what is the weather today, or what can I do in Singapore? But then after 7 days, I finally know that the answer is actually correct. But I already leave Singapore and I'm back in New York. So I don't think this is very practical for daily usage of AI. And then zero knowledge proof, everyone knows ZK doesn't, math doesn't lie. So once you generate the proof, you can actually verify it with the 100% correctness guarantee. But however, the computational overhead is even higher. It's currently like 100x overhead. And we think ZK probably will get there with like in the next 5 years, but currently it's not usable at the moment. So what we invented is that we proposed another new verification mechanism. We call it proof of sampling. This is a new verification mechanism invented by our team and also our advisors, Professor Raluca Adapapa from UC Berkeley and Professor Siamat Moalami from Columbia. It's a sampling-based verification mechanism. So instead of challenging all the results, it only checks a certain portion of the results. So most of the cases, only one node we call asserted will generate the result. But then with a certain chance, this network will ask another node to regenerate the result. And once we receive the two results, we'll compare the results. And if the results are different, it will initiate an arbitration process. And after the arbitration process, the dishonest node will be punished with a high amount of penalty. And we can use math to prove that depending on the stake, slashing amount, and a reward, you can actually derive a formula for the threshold such that as long as the chance of checking is higher than that threshold, the system has a pure strategy Nash equivalent. This means that everyone in the node will behave 100% honestly if they are rational and try to maximize their own benefit. And we think we also see a huge potential of these verification mechanism because just like fraud proof and ZK, proof of sampling is not only useful for AI inference, it's actually useful for many other services. So including AI training, AI fine-tuning, and some services outside of AI, let's say like L2 rollup and also data availability. So we're trying to build this as a generalized AVS. We're working with EigenLayer, Kerak, Exacore, and a few other risk-taking protocols. Together, we'll build this like generalized AVS so that other AVS service builders can utilize our verification mechanism to secure their own services. And the last goal we're trying to solve is privacy. Everyone knows like you have the freedom of speech and you want to protect your own data. And there are many different ways to solve this. And the most practical way is to leverage TEE, which is like trusted execution environment. This is powered by the hardware of GPUs. NVIDIA launched this confidential computing module on H100s and B100s GPUs, and it currently has a very great performance. It only reduced the computation, the performance by only 1% when you do inference. And so we're working with researchers and partners together to solve the privacy problem. So once we finish all these different infrastructure, some have launched, like the orchestration layer and inference engine, and some have passed the research stage and are currently being implemented, like the verification layer and privacy layer. And we're going to launch our blockchain as well. So around the end of this year, we'll probably have we'll have the testnet of everything. And that's what we call the first stage of Hyperbolic, which is infrastructure stage. And entering next year, we'll have the second stage, which is applications and economy stage. So at that time, there will be many new AI applications that cannot be created in Web 2, but can create it on Hyperbolic. So for example, starting from GPU, some projects can easily tokenize the future usage and current usage of GPUs, and people can start buying that. And then maybe some DeFi developers can also build GPU future exchange and spot exchange. So as a trader, now if I think the GPU provides a price of H100 will be $2 in November, but currently on the future exchange, it only costs me $1.5 to use to buy the November shares, then I will definitely buy it to kind of do this speculation. It's also good for the GPU providers, because as the GPU providers, now once I provide a machine to our network, I already can monetize the future usage of my GPUs, and that gives me higher liquidity, more capital to bring more compute to our network. And on the AI side, a lot of people talking about AI model revenue sharing or like user-owned AI, which is the near thesis. I think this is also can be powered by Hyperbolic because someone can easily tokenize an AI models. And as a developer, now I no longer need to spend a lot of time talking to different investors, trying to raise millions of dollars to get enough capital and compute to train an AI model. But instead, I can just have this proposal, I can launch these tokens, and I can invite a community to contribute to my idea, right? Some can provide GPU resources, some can provide capital, some can provide data. And once I actually finish the AI model, I can host it on Hyperbolic's inference service. Our inference service will be compatible with the token standard and distribution rule that they set up. And all the revenue that come into the AI model can be redistributed back to the different token holders and contributors. And so we currently, we just announced a partnership with Black Forest Lab, which is like one of the strongest image generation labs, that they build Flux, which is the state-of-the-art AI image generation model. We're exploring the revenue sharing idea with them. So every income that goes into our inference engine for that specific model will be, we will share the revenue with them. And I think this is how we can actually build an open, collaborative AI community without just taking everything for free. And the last stage that we envision will be hyper-intelligent stage, because we think in the future, AGI won't just be a single monolithic giant AI model. It will actually be modular. So we'll have a huge AI agents network such that different AI agent is capable of solving different questions in different domains. Like some are good at math, some are good at reasoning, some are good at legal, some are good at medical. And then every time when the user sends a request, our network will route the request to the agents that are capable of solving this question. And then these agents will collaborate together and try to provide a better answer compared to just one single generalized AI model. And this can be powered by, so as AI developers, now I can use Hyperbolic compute to train the AI model that I want, and then I can host it on Hyperbolic's AI inference engine. And then by having this economy element come into play, I can actually own the revenue that belong to myself. And I know this probably sounds a little bit science fiction right now, but maybe in 5 years, we'll start seeing this becoming true. The last page is like the ecosystem map. We know that in order to build this open AI ecosystem economy, there's no chance that Hyperbolic can build it by ourselves. So we're trying to partner with all these great partners, both in Web 2 and Web 3. Some are from universities, some are from AI research labs, some are like real AI, Web 3 AI applications builders, and we also have compute players and training service, risk-taking protocol, etc. together. And we think the future of AI is collaborative. So we want to partner with everyone, join us, and together we can build a bright future. Thank you.
Do you want to take questions?
Okay, so I think now is the Q&A session. So if you guys have any questions, feel free to raise your hand. Yeah. Sorry, can you?
Yeah. Okay. So I just wonder your final vision of Hyperbolic ecosystem, also your final vision of user-owned AI or decentralized AI.
Yeah. So I think just like what I said, the ultimate vision of Hyperbolic is we try to build the open AI ecosystem and economy of the people, by the people, for the people. And what does it mean? It means that if you have a lot of data, then you are able to contribute your data to the ecosystem so that other people can use it. And you can own the data, and you can share the revenue that come into this data. And the same for compute. If you have compute, right now probably you can just only monetize that based on the current market price. But what if you can actually contribute to the development of an AI model, and you can share that ownership, partial ownership of the AI model? And I think this is how we can outcompete. We can compete with centralized AI companies, because right now, like all these different centralized companies, they have like hundreds of thousands of GPUs. By individuals, there's no way that you can, by ourselves, there's no way that we can just have enough compute and enough data to win the game. But actually, Ethereum, when it was like the proof of work stage, it actually have 20 times more compute than just OpenAI. And if we can actually build this collective community that everyone can contribute what they have, there's a chance. And I think I'm very confident that in the future, we can actually build comparable AI models that have the same performance or even better performance compared to centralized AI models.
You mentioned about kind of encouraging the ecosystem to kind of build together. I think as we're seeing, like there are lots of crowded elements in these layers. So from your lens, what should people be building, and how can we complement the existing compute layers and aggregation layers that already exist?
So yeah, so there are like many different layers in the AI ecosystem. So like infrastructure-wise, you can build GPU network, you can build AI services like AI inference service, AI training service, AI fine-tuning service, etc. And then there are also people building like data layer. So data labeling, like you can help label data, or like data cleaning, data storage, etc. And so it depends on expertise. If you are a very you are an engineer that very deep in infrastructure, then I think building infrastructure is a good place for you. But if you are more like an AI developers who want to build like open source AI model, then you can leverage this infrastructure, and you can issue tokens, and you can like try to build this proposal, allow people to contribute all these resources to you, and you can build this like state-of-the-art AI model. And as a normal people, then maybe you can compute. Everyone has their personal compute, so they can easily join our network to provide compute. They can also participate in those like data labeling event, campaign, or like they can also try to provide human feedback to AI models. And those are also very important, and that can also help the development of open source AI. All right, so thank you, everyone. Feel free to come to me after the talk.